Today we're going to talk about properties of exponents. Again, with exponents, I cannot stress enough to write out all your steps. Start with the definition if you need to, but write out all your steps so that you know where your answers are coming from. Once you get really used to what's going on, it's okay, but for right now in your workbook and in your notes, you need to write down all the steps that we're doing. The product rule for exponents. If we have two things with the same base, we add our exponents together. Why does this happen? Let's look at 2 to the third times 2 to the fourth. 2 to the third is 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2 times 2. If you look at what that is, that's 1, 2, 3, 4, 5, 6, 7 2's multiplied by itself. By the definition of exponents, that's 2 to the 7th. If you look here, 3 plus 4 is 7. So when we have the same base, we add our exponents. If we have the same base but we're dividing, we get the quotient rule. A to the m divided by a to the n is a to the m minus n. Does this make sense with what we know about negative exponents? We know that a to the m over a to the n is equal to a to the m times 1 over a to the n. That 1 over a to the m is a to the negative n. So a to the m times a to the negative n. Well, we just found out what the product rule was. It said to add our exponents. So that's a to the m plus a negative a n, which is a to the m minus n. So what we know about negative exponents, what we learned a couple sections ago about negative exponents, even has this make sense for us. The other way to look at these is if we have 3 squared divided by 3 to the fourth, that's equal to 3 times 3 in the numerator and 3 times 3 times 3 times 3 in the denominator. And if we have the same factor in the numerator and the denominator, we can divide those out. When there's no factors left in the numerator, we're going to put a 1 there, and then in the denominator we have 3 squared, so 1 over 3 squared, which is 1 over 9. Our product rule states if we have a base and an exponent to another exponent, we multiply our exponents. Why does this happen? If we have x cubed squared, that's saying x cubed is multiplied by itself 2 times, because that's, for the squared, our base is x cubed. So that's x cubed times x cubed. If we used our product rule, we could do 3 plus 3, which is 6, or we can go all the way down to the definition and do x cubed is x times x times x. Another one is x times x times x. X is multiplied by itself 6 times here, so it's x to the 6th. But notice that's 6 is 3 times 2. So this one we're going to use our definitions and then show our work. So this is negative 3 squared. So the negative is part of the base squared. So this is negative 3 times negative 3 times, now this is negative 3 cubed, so negative 3 times negative 3 times negative 3. We have 1, 2, 3, 4, 5 negatives, so our final answer is going to be negative. And then we have 1, 2, 3, 4, 5 3s, so negative 3 to the 5th. This is 5 squared to the 4th power. So that means we're going to write it out. That's 5 squared times 5 squared times 5 squared times 5 squared. Writing that out further, that's 5 times 5 for our first 5 squared. 5 times 5 for our second 5 squared. 5 times 5 for our third 5 squared. And 5 times 5 for our fourth 5 squared. So that gives us 1, 2, 3, 4, 5, 6, 7, 8. 5 times itself 8 times, so 5 to the 8th, which is 2 times 4. The last one we're going to write out using the definition here, 3x to the 7th over 3x to the 4th. So 3x to the 7th, 3x is our base, so we're going to multiply that by itself 7 times. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then 3x to the 4th in the denominator. And just like before, if we have something in the same thing and same factors in the numerator and the denominator, they can divide out. So we have a 3x to the 4th and a 3x to the 4th. So that is 3x is our base cubed. And we can also write that as there's 1, 2, 3. 3 times 3 times 3 is 27. X to the 3rd because it's x times x times x. Now we want to simplify the expressions showing the steps using the properties. So this one is a product property, so that means we're adding our exponents. So that means we're going to do the base is 1/3, and we're going to add our exponents. So it's 4 plus 7. I want that step shown in your workbook so that you understand what's going on when you keep working. A lot of times students mess up the properties because they're not writing their steps down. That becomes 1/3, which is our base, 4 plus 7 to the 11th. Now we have x to the 2/7 times x to the 3/7. Remember, those were exponents, and they, even though they're rational exponents, even though they mean radicals like they did before, it still works with the same properties. So this becomes x to the 2/7 plus 3/7. So that's x to the 5/7 because we have a common denominator already. All we need to do is add the numerators. This one, there's a couple steps to this problem. Let's make things smaller before we make things bigger. So let's do the quotient rule first. So that's a to the 5 minus 2 cubed. We're going to do the quotient rule. We're going to subtract 5 minus 2 first. So that's a to the 3rd, that's 5 minus 2 cubed. So a cubed cubed. So that's, now we can multiply our exponents. So that's a 3 times 3, which is a to the 9th. We're still showing all our steps for these. This is f. It's a division, so we're going to subtract. So that's f to the 7/3 minus 2/3. Again, we have the same denominator, so we can just subtract the numerators. So that's f to the 5. 2/3. 7 squared to the 7th. This is an exponent to an exponent, so we're going to multiply. So that's 7. 2 times 7. Again, write your steps out. So that's 7 to the 14th. This one, the base is x plus 2. And it's an exponent to an exponent, so we're going to multiply. So x plus 2 times x plus 2 to the 2 times 5, which is x plus y, not x plus 2 to the 10th. Let me erase that one. That should have been x plus y. So it's x plus y squared to the 5th is x plus y to the 2 times 5, which is x plus y to the 10th. Now we have negative exponents, and we don't want to include negative exponents in our final answer. So this first problem is just a recall that x to the negative 5 is 1 over x to the 5th. Remember, this doesn't change the sign of the fraction. It just moves the exponent or variable to the denominator. This one is negative of, remember that negative's on the outside, so it's the opposite of whatever we end up here. So we're just going to keep that negative on the outside. B to the negative 3 to the negative 4. Exponent to exponent we multiply, so this becomes B to the negative 3 times negative 4, which is the opposite. We're going to keep that out there. Negative 3 times negative 4 is positive 12, so b to the 12th. This one is a division. It's the quotient rule. So we're going to do c negative 4 minus 13. So negative 4 minus 13. C to the negative 4 minus 13 would be negative 17. But in the end, we don't want negative exponents in our answers, so we have to change that to 1 over c to the 17th. This one is a multiplication, so we're using the product rule. So that's 3.5 as our base, and then we're doing 3 plus a negative 9. 3 plus a negative 9 is negative 6. So 3.5 to the negative 6, which is 1 over 3.5 to the 6th power. If you have something like this, you don't need to evaluate it unless it was one of those perfect powers that we talked about in the previous section that you should know how to do. That's it for today. We'll talk to you tomorrow.